In this video, we are going to look at a couple of things which are going to be very helpful for us in doing quick computations. The first is base numbers. Now, you know that our number system is a decimal system, right? Which means any number represented by the digits 4, 3, 6 written in succession is actually 4 multiplied by something plus 3 multiplied by something plus 6 multiplied by something, which is 6 is multiplied by the 0th power of 10, 3 is multiplied by the first power of 10, and 4 is multiplied by the second power of 10, right? So this is how a number represented by 436 is actually computed. Now clearly the base here is 10, right? For a decimal system the base is 10. Now all the numbers, that means all the numbers, all of these, they are base numbers, right? So 10 to the power 0, which is 1, is a base number. 10 to the power 1, which is 10, is a base number, and so on. Now you would notice that a base number would starts with 1 on the left, so 1 is the leftmost digit, and it would have zeros after it, or maybe no zero after it, right? So all of these, they are base numbers. Now the next concept that we'll talk about is the concept of a complement. Complement is an important concept, and we are going to see a lot of usage of this concept in the subsequent shortcuts that we are going to learn. Now complement is a number which completes any given number. So I'll again start with the number 436. So I'll define complement of a number, or complement of 436 as another number, right, which when added to 436 gives us the next largest base number. So the base number which is just bigger than 436, the smallest base number bigger than 436 is 1000. So the complement of 436, this number, is 1000 minus 436. So if we subtract, generally the way we subtract is we subtract 6 from 10, we get 4, then this is 1 short, 9 is left here, so we get a 9 minus 3, 6, then again 9 is left here, 9 minus 4 is 5, right? Now what we want to do right now is speed up our computation of this complement, right? So 564, we just want to speed it up. So speeding up is no rocket science. What actually happens is, so whenever I'm subtracting 436 from the next highest base number, which is 1000, what I'm actually doing is all the digits of this number whose complement I'm trying to find, so the rightmost digit is subtracted from 10, right? Whereas all the rest of the digits, because they lend 1 over, right? So they are left with, instead of a 0, instead of a 10, they're left with 9. So I'm actually subtracting 3 from 9 and 4 from 9, isn't it? So it's just another way of doing the same computation, only it is simplifying the way we look at it. So I'm looking at one digit at a time, and the way I'm doing it is I'm subtracting the rightmost digit or the ones digit from 10, and all the rest of the digits I'm subtracting from 9. So I get a 9 minus 3, 6, and 9 minus 4, 5, 564, right? So let's do another complement. Let's take a bigger number. So let's say 4, 3, 5, 7, 9. So I got to find the complement of this number. So straight away what I'll do is, for ones, I'll subtract the ones digit from 10, right? So 10 minus 9 is 1. Now all the rest of the digits I'm going to subtract from 9. So 9 minus 7, 2. 9 minus 5, 4. 9 minus 3, 6. 9 minus 4, 5. Right? So 56,421 is the complement of 43,579. However, there may be a couple of special cases. So the first special case that I'm going to talk about will have zeros in the end. So let's say we have to find the number of a complement which looks like this, right? So what I have is there's no non-zero number in ones place. There are a couple of zeros in the ones place. So not to worry. This is again still as straightforward as this. The only thing which is different now is that I'm going to subtract. So these 0 and 0, they need no special subtraction because I'm going to subtract this from 100,000, isn't it? So the base number, which is just bigger than 46,600, is 100,000. So when I write 100,000, so these two zeros are going to be subtracted from 0. So there's no sweat in doing this. I just straight away write these two zeros. For the rest, 436, I'll do the standard method. So the first digit which occurs after the zeros are finished, are done, gets subtracted from 10. So 10 minus 6 is 4, and the rest, they will be subtracted from 9 each. So 9 minus 3 is 6, and 9 minus 4 is 5, right? So now I'm able to handle the complements of numbers which are multiples of 10, or they have zeros in the right hand side, right? The second special case that I'm going to look at is when we have decimals, right? So let's say we have 436.92, right? So if I have to find the complement of this number, again the complement of this number is going to be 1000 minus 436.92. What I will do is I'll use the same methodology, right, except that I'll start calculating my complement from this digit. So this digit again subtracted from 10. So 10 minus 2 is 8, and all the rest of the digits subtracted from 9. So 9 minus 9 is 0, and then 9 minus 6 is a 3, 9 minus 3 is a 6, 9 minus 4 is a 5. Now all I need to do is plant my decimal exactly where it is on the other digit. So I'll just plant my decimal here, and 536.08.08 is my complement of this number.